So today what I'm going to teach you guys is how to solve a quadratic inequality. Now first of all, what is a quadratic inequality? Now a quadratic equation is what happens when you have your equation where the highest power of x is a 2. And then an inequality, remember, is when you have one of our four inequality symbols. They can be a less than or equal to, greater than, and greater than or equal to. Now, when you get a quadratic inequality, your first step for me is to identify whether you have a perfect square quadratic inequality or a non-perfect square inequality. Now, to determine which one out of the two you have, the main defining factor of a non-perfect square is our lonely x term. So for example, if you have a look at this equation here, it says 2x squared plus x minus 5 is greater than 0. What you need to notice in this equation is that the highest power of x is 2, meaning it's a quadratic. We have a greater than symbol, meaning it's an inequality. So we have a quadratic inequality. And we have a lonely x term where the x is to the power of 1. Therefore, it is a non-perfect square quadratic inequality. So with these two types of quadratic inequality questions, I'm going to teach you how to solve both of them. Now, first of all, we're going to look at a perfect square question. When you get a perfect square quadratic inequality, there are two steps that you need to follow whenever you solve these types of questions. Now, the first step is to make your perfect square the subject, and then your second step is to use our rule. Now, your two rules are, first of all, if you have x squared is less than a squared, meaning you have x to the power of 2 is less than a constant, your solution for x will lie inside the negative version of the square root of your constant and the positive version of the square root of your constant. The second rule you need to memorize for me is that if you have x squared is now greater than a squared, meaning your highest power of x2 is bigger than a constant, your solution for x will lie on the outside of the negative version of the square root and the positive version of the square root of your constant. So essentially you need to memorize for me, if it's less than, it lies inside, and if it's greater than, it will lie on the outside. So let's have a look at these three examples. In all of these examples, what we are going to do here is to solve for x. So in the first question, I have x squared is less than or equal to 9. So in this question, note for me that the highest power of x is 2, therefore it's a quadratic. I have a less than or equal to symbol, therefore I have an inequality. So it is a quadratic inequality question. Now remember, for your quadratic inequalities, you're going to determine, is it a perfect square or a non-perfect square? Now here, I see that there is no lonely x term. No lonely x term means that it's not a non-perfect square. It's a perfect square quadratic inequality. So for these questions, we have two steps. First step was to make your perfect square the subject. Here my x squared is already the subject in the question. I don't need to change anything. I move on to step 2. Step 2 is to use the rule. Now your rule differs depending on whether you are less than or greater than. In this case, we are less than. If it's less than, the rule was that it lies on the inside. So x squared, square root of it is x. It lies on the inside of the square root of the constant on the right hand side, which is 9. So square root of 9 is 3. On the left hand side, it's the negative version of 3, so minus 3. And on the right hand side, it's the positive version, so positive 3. And so here we've solved for x. It says x will lie between, and it can be equal to minus 3 and positive 3. Now let's compare this, guys, to question 2. In question 2, we have x minus 1 all squared is greater than 16. What you notice in this question for me is, again, the highest power of x is 2, and I have an inequality symbol. Therefore, once again, we have a quadratic inequality. Now, this is clearly a perfect square quadratic inequality because my x is all in brackets to the power of 2. So once again, for a perfect square quadratic inequality, we have 2 steps that we're going to use. Now, your first step was to make the perfect square the subject. Again, here, the perfect square is already the subject. We don't need to do anything. I can move on to step 2. Now, step 2 was to apply your rule. Now, remember, your rule is dependent on what symbol you have. Here, I have greater than. If it's greater than, the rule was that it lies on the outside. So, we take the square root of my perfect square, which is x minus 1. It is going to be less than the negative version of the square root of your constant. So the negative version of the square root of 16 is 4. Then we have a second part. The second part is that x is greater than a, meaning the square root of my perfect square, which is x minus 1, will be greater than the positive version of the square root of my constant 16, which will be positive 4. Now here, after you apply your rule, you're not done with the question yet. Question wants you to solve for x, which means you need to make x the subject as well. So in my first equation, to make x the subject, I chuck the 1 over, that's minus 3. In my second equation, to make x the subject, I chuck the 1 over, it becomes positive 5. Now that you have x the subject in your equation, you have answered the question, you've solved for x. So, comparing question 1 and 2, all you need to remember is that if you have a perfect square and it's less than, the answer lies in between. Whereas if you have a perfect square and you have greater than, the answer lies on the outside. Just don't forget, after you apply your rule, make sure x is the subject as well. We'll quickly do one more question, question number 3. Here I have 1 minus x minus 1 all squared over 3 is less than minus 2. So in this question, guys, we have a quadratic inequality. So then you determine perfect square or non-perfect square. X is in brackets all to the power of 2. So it's a perfect square inequality. You jump into your first step. First step is to make your perfect square the subject. Now here, my perfect square is not the subject yet, unlike question 1 and 2. So we need to do that first. To do that, I'm going to get rid of my denominator. To get rid of your denominator, you cross multiply it over to my right hand side. It will be less than 3 times minus 2 is minus 6. Then I'm going to chuck the 1 over. Negative x minus 1 squared will be less than minus 7. Divide the negative across. X minus 1 all squared is going to be a positive 7 on the right hand side. And just don't forget for me, if you have a less than, when you divide by a negative, it changes signs, it becomes greater than 7. Now we've done the first step. We've made our perfect square the subject. You can now move on to step 2, which is to apply your rule. Check what symbol you have. It's greater than. Rule for greater than is that your solution lies on the outside. So, square root of x minus 1 all squared is x minus 1 is less than the negative version of my square root on the right hand side, which would be minus root 7. And don't forget the second equation as well. X minus 1 will be greater than the positive version of the square root on the right, which is 7. Now, after I apply my rule, x isn't the subject in each of my equations yet. So one final step, I'm going to chuck all my constants over to the right to make x the subject. So x is less than 1 minus root 7. And for the second equation, x is greater than 1 plus root 7. So in question number 3, the only extra step we had in comparison to 1 and 2 was that our perfect square wasn't the subject yet. So we had to make it the subject before we can move on to step 2, which was to use our rule. So far what we've done is we've looked at how to solve a perfect square inequality. In order to do so, we went through our 2 steps. First one being make your perfect square the subject. Second one being use your rule. Now what happens, guys, if we have a non-perfect square inequality? Now remember, for a non-perfect square quadratic inequality, this is when we have our lonely x term. Now when we do have our lonely x term, there are going to be two different steps for you to follow. Now the two steps are, firstly, sketch a quick diagram. Your diagram only needs to be schematic. You only need to look for your concavity and your x-intercept. From this diagram, you move on to step 2 and you determine whether you want your quadratic to be positive or negative. Now I know this doesn't quite make much sense, so we're going to have a look at what they mean in examples instead. So same aim as before, what we're going to be doing in these questions is solving for x. In question 1, I have x plus 1 times x plus 3 is less than or equal to 0. Now, just do it inside your head for me. If you were to expand these brackets out, highest power of x is going to be a 2, so it's a quadratic. You have a less than or equal to symbol, so you have a quadratic inequality. Now, we know for quadratic inequality there are two types, perfect square and non-perfect square. Do you guys agree that when I expand this out, I'm going to have a lonely x term? Therefore, it is a non-perfect square quadratic inequality. For a non-perfect square, your first step was to draw a quick sketch. Now, to draw my quick sketch, I only need my x-axis and I find the concavity and the x-intercepts of my curve. Now the concavity of a quadratic equation is given by the number in front of x squared. So x times x is positive x squared. If the number in front of x squared is positive, my quadratic concaves up. Second thing I need is the x-intercepts, these two values here. To find the x-intercepts, you just let each of your brackets equal to 0. If I let the first bracket equal to 0, it's minus 1. If I let my second bracket equal to 0, it's minus 3. Minus 3 is smaller than minus 1, so minus 3 goes on the left-hand side, minus 1 goes on to the right-hand side. That's your first step done. All I've done here was I drew a quick diagram representing my quadratic by looking for the concavity and the x-intercepts. Now step number 2, it says you're going to then determine whether you want it to be positive or negative. So now looking at the question, this quadratic equation needs to be less than 0. In terms of a diagram, less than 0 means when you want it below the x-axis. So if this is my x-axis, below the x-axis refers to this region here, it will be negative. So therefore, the solutions for x inside this equation must lie between minus 3 and minus 1. And don't forget, if your original question has the equality symbol, your final answer also has the same equality symbol. So to recap, in question 1, we learned how to solve a non-perfect square quadratic inequality. To do so, there were two steps. First step, you sketch your curve using the concavity and the x-intercepts. Then your second step was to determine whether you wanted it when it was positive or negative. In terms of a graph, positive means above your x-axis and negative means below your x-axis. Now, I just also want to quickly point out, lots of students, when they see this question here, x plus 1 times x plus 3 is less than or equal to 0, what they will do instead is they go, oh cool, it's factorized on the left-hand side, I see a 0 on the right-hand side, this must means x plus 1 is less than or equal to 0, x plus 3 is less than or equal to 0. In each case, then they go ahead and make x the subject. And they get the solutions that x is less than or equal to minus 1 or x is less than or equal to minus 3. Now remember for me guys, this does not work. You can only let each of your factors equal to the right-hand side if you have an equals to symbol in the middle. As soon as you have an inequality symbol, so a less than or a greater than, you must solve your quadratic inequality via a sketch. You cannot equate each of your factors to 0. Alright? And then moving on to question number 2, Just one more example here. I have x squared plus 7x plus 10 is greater than 0. I see here that I have a quadratic, highest power of x is 2, inequality, greater than symbol. So, and I also have my lonely x term. So therefore here I have a non-perfect square quadratic inequality. To solve one of these, first step is to sketch. Now, in question 1, the equation was factorized for us, which made it easier to sketch. In question 2, it hasn't been factorized for us, but in order to sketch, we want it to be factorized. So factorizing this quadratic here, I get x plus 5 times x plus 2 is greater than 0. Now that my equation is sketched, it looks more like question number 1. It's easier to sketch my curve. When we sketch, we only need the x-axis because we're drawing a quick sketch. Look for your concavity first. The number in front of x squared is positive, so it is a concave up parabola. Second thing you need are the x-intercepts. To find that, you let each of your brackets equal to 0. From here, I get minus 5. From this bracket, I get minus 2. Minus 5 is smaller. It goes on the left-hand side. That's your first step done. You've sketched your curve. Second step is you determine when you want this quadratic. Do you want it when it's positive or negative? Question wants it when it's greater than 0, meaning positive. On a diagram, positive means when you want it above the x-axis. So it's above the x-axis for these two portions here. And so from this graph, you can conclude that it will be to the left of minus 5, it will be positive, so less than minus 5. And then to the right of minus 2, it will be positive as well. And so for question number 2, the only difference here compared to question number 1 was that the equation they give you wasn't factorized. So where you can, factorize it yourself so that when you move on to step 1, sketching the curve becomes a lot easier in order to find your concavity and the x-intercepts. So in summary, guys, what we learnt in this section here was to solve our quadratic inequalities. So you know you'll have a quadratic inequality question when the highest power of x is a 2 and you have an inequality symbol, which means you either have less than equal to, greater than, or greater than equal to. Now, your quadratic inequality questions were split into two types. You have perfect square and you have your non-perfect square. For your perfect square quadratic inequalities, there were two steps you needed to remember. First step, you need to make your perfect square the subject, and then step number 2, you apply your rule. Your two rules were, if you have a less than symbol, it lies on the inside, and if you had a greater than symbol, it will lie on the outside. Now, if you don't have a perfect square quadratic inequality, what you will have instead is a non-perfect square quadratic inequality. For those questions, you will also have two steps. First step is to sketch your curve by looking for the concavity and the x-intercepts. And the second step then is to look at that diagram and determine when you want it. If you want it when it is positive, you're looking for when it is above the x-axis. And then if you're looking for when it is negative, you're going to check when it is below the x-axis. And those there are the two types of quadratic inequality questions you might be asked. So I hope you guys learned how to solve a quadratic inequality from this section, and then I will see you guys next time.